What's up, guys? Let's take a look at another CodeWars exercise. This one's called Count Repeats, and like a lot of them on here, this one seems easy enough to describe in words, and then it gets hard when you start the code, but if you keep going, we're back to easy again, and we're going to end up with a nice, clean, expressive, short final answer. So how do we get here? Write a function that returns a count of characters that have to be removed, so this is going to be an integer, in order to get a string with no consecutive repeats. What does that mean? Well, if you have A and a bunch of B's and then C, your result is A, B, C, because it's like that entire group of B's became a single one. But if you have A and some other stuff and a second A, well, both of those survive to the end because the second A is a new group. It doesn't know about any other A's unless it's touching them. And then this is telling us that a space or any other character is treated the same. We don't have to only look for letters. So here's the thing. If you were to start coding this, you would say, we need to compare each letter to the adjacent ones. And so we're going to use the index with the +1, right? You'd probably do something like if text of I equals text I +1, and it would work great until you get to the last one, and it would say +1, error, we can't look outside the bounds. And then you go, okay, well, let's do -1 instead, and it would never even start because you get an error on the very first one trying to look behind itself. And then you have to add, well, if we're on the edge, we don't do it, but if we're normal, we do it. And it just becomes a mess. It's like the code is based on fear of what you're trying to avoid instead of what you're trying to do. So how can we instead say what we're trying to do, use some structures that are more robust and that can just handle any of these edge cases. You know, edge case is the term in programming for things that don't come up often, but they ruin your day when they do. And in this case, it's literally the edge of the list, either the right or left. Well, one of the things we've tried recently that is totally fine with handling different outcomes is a slice. You know, imagine you had 1 colon, and that starts at 1 and goes as long as it can. Maybe 1, maybe none, who knows? It's fine. If 1 is the last thing, it'll just give you what it can. If 100 is the last thing, it'll give you all of them between there and the end. So we'd like to use a slice if we could, and in fact I'm going to do that with another thing we've talked about recently that can also handle hitting the edge and being fine with it. So let's talk about zip. Zip is a way to take 2 sequences and zip them together like a zipper. So you line up the first of each, the second of each, and so on. And if we take, right now, text and then text shifted a bit, and we zip them, that means each one is going to be next to the neighbor, like the adjacent who would have been further ahead in the original list. And zip just goes as far as it can. It's fine. If it hits the edge and one of them has run out of gas and the other one still has some, we'll drop the others, who cares? Which is going to work in this case just fine because the last one doesn't need to compare to anything because the previous guy has already compared himself to him forward. He doesn't need to go backwards. And so what are we going to do? We're going to give these 2 names. Zip gives you a tuple every time you go through this, so we have 2 things. I'm going to call them left and right. And then what are we going to do with them? We're going to say if left equals right. And then what are we going to do for the whole thing? We're going to say how many times did that happen? How many times did left equal right in this loop? And that's the sum. So we've said go through these 2, original and offset, see how many match up. If they do, that counts as 1 because true is 1, and then we return it. And that would be just fine. That will give us all the tests pass. Somebody might say, you know what, this is too long. I don't like it sticking out that far compared to my other lines if this was a program with other lines. And they might do single character names. So we could go L and R. If you see L and R, you'd probably guess that they're left and right. And that looks fine to me. I could test it, or I'll hit attempt to do the bigger tests and make sure it passes everything. And this is pretty good. I would quibble with the names. You could go with some other things, char and next, or a and b. Actually, not next, because I think that's a function in Python that we don't want to overwrite. But in general, the names are fine. Let's see what other people have done for their solutions. Oh, that's nice. This person did exactly the same as we did. They just called it A and B. And that's fine. A and B don't tell us anything about the content. But if you see that, you know A is the first and B is the second, which is all that matters here. And this person used a function called group by. And it comes from the itertools, which has all kinds of ways to chain or find combinations or go through different loops in efficient ways. And so group by, I've never seen it before, but it must do the thing that we're talking about, which is each guy in a group with its adjacent neighbors if they are matching. Now, who knows? Maybe it's more efficient. Maybe it's really optimized code that can be faster than ours. Because one drawback with this is that you make another string. If you make a slice, it creates new space in memory to do a whole new string. And if the string was 1,000,000 characters, that could be an issue. I don't think they're giving us any huge ones here, and I don't think they're testing for that. But theoretically, it could be a problem. Let's scroll down a little bit more to see if there are any surprises from the others. We got another group by. We got someone doing the sum manually, just starting at 0, adding 1 as we go. And we've done that a lot recently, where we start with this, but we eventually rearrange to the sum function in order to save lines and express the thing we want to say first and foremost, instead of a bunch of setup before we get there. We got another zip just like ours. We got somebody using RE, which is regular expression, a way to search for text, or in this case, substitute text and do the syntax for, hey, look for this, do this, etc. That's probably all we're going to find. If we keep scrolling, we're going to see the same stuff over and over again. Looks like about 3 ways to do it. And all of them are totally fine. I would imagine the performance is close. Maybe this one is slower because it has to try things that don't work. This is kind of what I was talking about at the beginning of the things we're trying to avoid. But you know what? It works. This person got here. He's probably living a happy life. So that was a good one, because even though you see something like this and you think, how did the person write it? Did it come to them in a burst of inspiration in 30 seconds? Well, maybe. Or maybe they wrote a long way first and then condensed it. Most of all, they probably have done a bunch of these, and if you do a bunch of these, you see the patterns. So the next time you see one that involves counting, summing, testing, filtering, whatever, you'll have it fresh in your mind if you've done a bunch of similar problems, just like math class or anything else. And that's why we practice. Thanks.